So again, here's the final product. One more glimpse. So first things first, if you navigate to our club website, this beautiful page, on our downloads tab, we have the assets for today's workshop, which is appropriately labeled Unity Shaders Workshop for January 30th. So if you click that, it should bring you to a box page, which looks like this, and then you can just hit the download button up here, and that will download a zip file with everything you need. Basically, all we're doing today is writing the shaders. I provided a small scene with some scripts and some textures that I borrowed from online. All right, so we have this in here, and then if you want to open up Unity, so assuming you have Unity installed, go ahead and open up the Unity Hub. It should look like this. Man, I have a lot of stuff in here. So go ahead and create new project, the big blue button, and that'll pull up a bunch of templates. I'm using the editor version 2022.3.2, but any newer version, like 2020 or newer, should be fine for this. And then go ahead and name it whatever you'd like. I'm just going to call it GDC Shaders. And then after you have done that, go ahead and create the project. It should have defaulted to 3D Core as the template, and if it didn't, just go ahead and make sure that's selected here. Otherwise, you should be fine. So, yeah, that's fair. Well, okay, surprise, we're not actually going to write any code. I decided against it for a couple reasons. One, so Unity has, in the past, usually how you, or even now with some things, how you usually write shaders is you actually write code and you write a program. That's fine and dandy, but it's really hard to learn what you're doing, and the autocomplete isn't too good. So Unity also has this thing called Shader Graph, and it's kind of like drag and drop, where you can create nodes and you can like link them together and stuff, and it makes creating shaders a lot easier as well as like visually appealing. You'll see what I mean when we start doing it. But I decided just to do that. It's come a long way since they first came out with it. So at this point, like, there's no reason, unless you're doing a very specific shader, like if you're doing like ray tracing or something, well, actually, I think there's built-in stuff for that. I don't know. There's probably some niche case where you'd still need to write code in order to get a shader to work, but in most, like 95% of situations, you can probably just use Shader Graph. So that's what we're going to do today. Cool, so after your Unity project has loaded up, some people might still be loading, that's okay. I'm just going to import the assets. The easiest way to do it, so after you have downloaded it, you'll have a zip file in your downloads folder, or wherever it downloaded to. Go ahead and extract that, or unzip it. And then after it's done that, I would just take the folder. So the folder that's inside the folder that you extracted, I'm just going to drag and drop that into the project window here at the bottom. Might be in a slightly different place for you.
So I should click the add button?
Yeah, so inside of here we have a scene, which you can open and it'll be just a bunch of pink because nothing's working. If you want to go ahead and open that, actually, that's what we're going to be using today. So just double click on it, it should automatically open. You'll see a pink box. And then there's some scripts that I wrote. This is just some small stuff to like make the light spin around and stuff, nothing you need to worry about. And then inside of here we all have the textures that we're going to be using, which I will explain in a bit as well. Some of them might be a little straightforward. So I actually forgot to delete those. So we're going to delete those. If you have them, you can go ahead and delete them too, because I'm going to show you how to make them in case you make a project and those aren't there. So yeah, basically Unity has a system in place where you can create a rendering pipeline. And what a pipeline is just like a process that it follows in order to take stuff from the game and render it to the screen. The default pipeline is okay. You can create some basic shaders with it. But with shader graph and with like cooler looking stuff, you want to use a different pipeline. So Unity has the default one. It has the universal render pipeline, which is just like a generic catch-all pipeline that you can use for shaders. And then there is the high definition render pipeline, and that's the one that's going to produce like really good looking graphics. So if you're making a high-end game in Unity, that's probably what you're going to use because it's going to look a lot more professional. However, it's also more demanding for like higher end computers, so it's kind of what you want to do. If you're making like a mobile game or like a simple game, you know, you can probably do with either the default or the universal one. But if you want to make something a little more elaborate, I would go with the high def one. So how do we actually install that? If you go ahead and click on Window at the top on the menu bar, and then go to Package Manager, there's a pretty easy way to install it. So this will pop open this window here. And then we will go to this Packages drop down at the top and switch it to Unity Registry. So this will list all of the different packages that Unity basically has created for you, which there is quite a lot of them now, which is really nice. So if you're looking for some like tool you wish Unity had, they probably have it. It's probably in here. I didn't even know they had Python scripting, so that's cool. But anyways, the one that we want is Universal RP. I don't know why they abbreviated RP and not Universal, but go ahead and click on that one and then click Install. Yeah, shaders can be pretty cool for a lot of things, making cool games. I think in a lot of situations, shaders are mostly used for like bringing a game to life. You can create grass with it, for example, and it's a lot cheaper than creating a bunch of little grass objects because then the Unity has to draw all of them every time you play the game. But you can use a shader, and then you can say the shader, you know, if it's within this distance from the camera, draw a little sprout of grass how many ever times. And it's a lot cheaper for the graphics card to do that than it is for the CPU. So, okay. So after that is installed, you can go ahead and close the package manager, I believe. However, it's not quite ready to use yet. So now we need to create a pipeline asset and actually tell Unity that we want to use this pipeline that we have installed. So in your assets folder or just wherever you want to put it, in the project window here, go ahead and right click and then hit create, and there's this like huge list. We want the very bottom option, the rendering, and then the top option of that. So we go to right click, create rendering, and then URP asset with universal renderer. Make sure you don't click the 2D one since we are doing 3D stuff. Okay. And that will create this. You can go ahead and name it like pipeline or something. That's what I'm going to name it. Doesn't matter. After you've done that, then it creates a pipeline. We're not going to change anything. If you were wanting to do some like super fancy shadows or something post-processing, you'd probably want to mess with this. We're not going to. We're just going to assign it. So in order to assign it so Unity knows to use it, go ahead and go to Edit, and then go to Project Settings. That'll pull open this menu, the Project Settings menu. Go ahead and click on the Graphics item menu on the left there, and you'll see this screen.
Oh, we go back to Window?
No, so this is in Edit and then Project Settings. So yeah, this is used to change different things for the specific project that you're working on. So you can change how the physics work, how the input works. a whole bunch of stuff. Quality. Shader graph even has a menu in here. So once you've done that, there should be this this long field here, and then at the right there's a circle with a dot. You can click on that and then just click on the pipeline asset you created. And then if you click out of it, say it'll take some time, just hit continue.
So click out of it?
Yep. And then hit the continue button.
Thank you.
And it should auto load all this stuff that we were just going to leave here. And then you can just close the window. Good so far?
All right.
Cool. So now let's actually create a shader so we don't have to look at this pink garbage on the screen. If you would like, you can go ahead and create a shaders folder. So if you right click, create, and then folder, we'll create a new folder. I'm just going to call it shaders. And we will create 3 different shaders. And so then inside of here, you go into the shaders folder again, you can right click, create, and then we will go to shader graph URP, which is the universal render pipeline, and then we want to do, I think just a lit shader graph is going to be fine. And then let's do the water shader first. So you can name this like water shader or something similar.
Do that last part again.
Yeah, 1 second. So yeah, right click, create, shader graph, URP, and then lit shader. Yeah, they should really try to lump some of this together. Do we really need all the animation stuff spread out like that? There's just so much stuff. Yeah, exactly. But yeah, if you were doing an actual shader with code, you would just go here in this shader section, and then it has the same similar options: surface shader, unlit shader, compute ray tracing shader. But this would be with actual code. So shader graph, this will create a slightly different thing, which is what we want to create some basic stuff. So. And then after you've done that, go ahead and double click on it. Actually, we're going to let's create another shader quick. Do the same thing. Create shader graph URP, lit shader, and just call this one default shader or something. Okay, and then open the default shader by double clicking it. So you can see this menu that's in here. I'll make it bigger so it's easier to see. Yeah, if you want to make a window easier to see, if you go to the tab header and then you just double click on it, it'll maximize the window. Yeah, so it'll make it a lot easier to edit this stuff if it's full screen, in my opinion.
So I double click it?
Yeah, you can double click on the... Okay, so inside of here, there's just some basic stuff. Or I wouldn't say basic, but the starting stuff, I should say. You see vertex with some different things, and you see fragment with some different things. So normally how shader graph works is you can actually do the vertex and the fragment that I talked about earlier together. We're only going to do one or the other just for simplicity here. But these are all the outputs. So these are all the different things that you can change per vertex or per fragment. Yeah, so a vertex is basically a point on a model or a cube. So because everything's drawn out of triangles, if you didn't know that already. So a vertex, say you have a cube, there's 2 triangles on the front, 2 triangles on the side, and each one of those makes a square for each side. And then a vertex is the points where the triangles meet together, or at each end of the triangle. So the vertex shader is going to be changing those dots, the positions and stuff. And then the fragment is after it does all the vertex stuff, it'll apply the vertex shader, then it'll do the fragment shader. Then after it starts drawing that triangle on the screen, that's when the fragment shader will come in and you can change the color. You can change the normal, which is used for lighting. So if you wanted to because the normal is basically the direction that the face is, so that like when the light bounces off of it, it knows which way to bounce. You can also change how metallic it looks, how smooth it looks, etc. We're just going to mess with the color and some other stuff. So for this default shader, we're just going to throw together a shader that just renders a texture, just as a base case. So if you want to do that, on the left side, just anywhere in this open blank area, go ahead and right click and then hit create node. And this will bring up this create node window. You can dig through it if you want, but I'm just going to search since I know what it's called. We would like to get a sample texture 2D. It'll be this one here, sample texture 2D. You can double click on that.
Wait,
Yep, so that'll bring up this menu. You can see there's a white square. So basically what a texture sampler does is it'll take a texture that you have, like an image of some sort, and then it will take the positions of the vertices or the texture coordinates, and it will map those to the texture. So say that you have a cube, the top left corner will then map to the top left corner of the texture in this case, and same with the top right, top left, whatever. And that's what we're going to do. So if we want to just simply assign a texture, like just a static texture to use, you can see how there's a circle with a dot here. Where it says none texture, you can click on that, and I'm going to change it to the GDC logo. And then now you can see that preview, it shows it there. So if we want to, now that we have this texture here, it knows to use the texture. How do we actually get it to render onto something? That's when we want to override the fragment color. So right now it's just going to be white, but we want to say to use the color that it's getting from the texture. And it's really simple. There's this RGBA4, this pink dot. You can drag and drop that into the yellow spot next to base color. And then after if you do that correctly, you will see how it creates a line that goes from there to there. And that means it is linked. So now all this shader is going to do is it'll take the model data, it'll map that to the texture, and then it'll render it. So if you want to hit Save Asset in the top left of the window, it'll save. I'm going to double click this again to go out of full screen mode. So for whatever reason, these don't save automatically, and they don't save with Control S. You have to click the button to save them, just so you are aware. But that like recompiles it, I'm pretty sure, is why they do it that way. So now that we've done that, let's go to our scene view where it's all pink. And let's click on the normal cube. You can click on that in the hierarchy if you can't find it, since everything is the same color. And then in your project window, you can see these two shaders we've made. There's like little arrows next to them, and that'll expand, and you can see this material, this like sphere. Yeah, take this sphere and then, oops. So yeah, after you've clicked on the cube, over here in the inspector window, sorry if I'm jumping around a lot, somebody let me know if I'm going too fast, but in the mesh renderer component, we're going to assign the material there. So this part that expanded from the shader, you can just drag that into here, and you should see the cube come to life and actually have a texture on it.
got it.
Yeah.
How do you drag our default shader?
Yeah, so if you click on the cube in the hierarchy, and then on the other side on the inspector, you have to hit the drop down for materials, and there should be like element 0. You drag it into there. And that's just how you that's the general process for creating a shader, the shader itself, and then applying it to something. So now we're going to actually do a shader that does a little more than just do a texture, since that's probably why you're here. So let's go back to the water shader and do this. So our water shader is going to be a lot more complicated than what we just did. Basically, what it's going to do is we will change each vertex in the shader. So the plane, the big box that's pink, that's a plane that Unity has like just in default. It has essentially just a grid of squares, which are all triangles. And so we can take that and we can make a shader that will take each one of those points, and where then we can apply some noise to it to make it look like it's rolling hills, like some waves, or some basic, the water isn't totally still. And so in Unity, like an actual scene, the object itself is still flat. This is all just visuals that are coming from the shader, which is pretty cool. So let's start doing that. I'm going to make this full screen again. So I'm going to go far out to the left, not like too far, but enough. And you can always move things around later if you need to. Well, let's start with the easy part, actually. So despite the fact that we're going to mess with the vertex, we also want to render the texture as well. So we're basically going to do the same thing that we did on the last one, again, but with a different texture. So if you remember, go ahead and right-click Create Node, and we want the Sample Texture 2D. And then this time, when we select the texture, go ahead and select the water texture. Unless you want to make the water look like the logo. I mean, that's cool too. And then again, just drag and drop that RGBA, the color, into the base color, so that we have that visual. This isn't like required for this, but it makes it look nicer. So that's all that part is. So we are not going to touch the fragment at all. The colors are done. If you wanted to make this look fancier, like if you wanted to have some transparency or something, you could actually probably just make the texture transparent. That'd probably be easier, but you could do that in the shader as well. But we're just going to mess with other things. So how we're going to tackle getting the water to flow up and down is by taking the current time of the game, which is like a built-in variable we can reference, and then we're going to have it move over some noise so that it looks like the water is flowing up and down. And then we will apply that to each vertex based on its position. Hopefully that kind of makes sense. All right. So first thing we want to do is get reference to the time so we can use it. So if you want to go away on the left side, right-click, create node, and just search for time. Input basic time. Go ahead and import that. So it gives us a bunch of options. We only need the top one, which is fine. It'll just ignore the rest of them. And then we'll come back to that. And then now we need a way to tell it that we want to repeat this value as it moves over the noise. The way that we're going to do that is right-click, create node, and select tiling and offset. So this will take this time value and it will tile it so that it repeats over and over. And then for this one, so you can see how it has this like green, yellow, red preview. This is nice when you're working with the fragment shader, so you can see a preview, and we'll see this when we do the next shader. But for the vertex shader, it's not really needed. So if you see this like up arrow that appears here, you can click that and it'll make it a lot smaller, which I prefer to do because then when you're making a little more complicated stuff, it's not as bloated. So yeah, after you create a tiling and offset, go ahead and drag time into the offset at the bottom. Or I guess this isn't tiling it, that's automatic, sorry. But the offset, this is creating the offset for the tiling. And then now we want to actually get the noise value. So again, right-click, create node. This one is called Simple Noise, which you can see that there's different variants as well. There's Voronoi, gradient noise, noise sine wave. We're just going to use the simple one for the sake of the tutorial. So you can see the preview on this one. It just looks like a bunch of
Static.
Static, yeah. So that's basically all noise is, except for it's not completely random. If you were to zoom in really far, it would look like a bunch of rolling hills. Think like Minecraft worlds when Minecraft was a baby in 2011. So we're basically going to use that. Again, I'm going to minimize it because we don't care. And then I'm going to take the out from tiling and offset and plug that into the UV, the top one in simple noise. So basically what this is doing so far is it's taking the time, feeding it into the tiling and offset, creating a position out of it basically, and then it's plugging that into the noise. So we can say, get the noise at this position. The scale, I can't remember what I set that to. I should have written it down. Oh well. We'll find out later. I think it has to be a tiny number, but we'll just leave it. And then, so now we want to take that noise, sorry, and we're going to multiply it by the normal vector. So the normal vector is the direction that it's facing. In this case, it's just up. I forget exactly why, but trust me. So yeah, right click, create node, and normal vector. Make sure you get the one that's exactly named normal vector. That'll look like this. Again, I'm going to minimize the preview. And then we also want to change, so on this one it has a space drop down. We're going to change this to object space. So when you create shaders, there's this concept of space. Basically, what type of coordinate system are you working in? You can see all the different options are here. You have, I actually don't know what tangent is, so I'm going to ignore that one. But you have the object space, which is like, it's relative to the object that you're drawing. You have the view space, which is basically, it's relative, everything is relative to the camera. And then you have the world space, which means everything is relative to the world as a whole. In which case it means it's not really relative to anything, it's more like objective. But we want object space because we don't care about everything else, we just care about the object. And then we will keep everything as object space to be consistent. So let's take the noise and the normal vector and multiply them together. Right click, create node, multiply. Again, we can hide the preview. And then, as you can see in the multiply, it has A and B as the two inputs. They each say 1 next to them. What's cool about shader graph is that since if we take normal vector, it's an out 3, it'll automatically update this to what it needs to be. So in this case now it's doing 3s, which is nice. And even though this isn't a 3, it's a 1, it will appropriately scale it or create like the appropriate vector so it can multiply it properly. Whereas like if you were writing this code yourself, you'd have to do a little bit of number finagling. It's not really too complicated, but it's cool how shader graph does this automatically for you. So now let's actually multiply it by the position. So we have basically what we've done so far is we're taking the noise, the water, and we have a position for that. But now we want to actually apply it to the position of the object. So if we were to just put the shader on like just visualize it, at 0, 0 in the world scene, you would probably just see like some water moving up and down if you were to like in a figurative sense. But what we want to do now is say, okay, let's apply that to the actual object. So it's moving those at the correct position. So below multiply, I'm going to create a position node. So right click, create node, position. Again, I'm going to hide the preview. And then I'm also going to change the space again to object, since we want it to be relative to itself, since we don't care about other stuff. The situations where you would use world or view kind of depends on what you're doing. World space is good for like lighting and stuff, I think, and then view space is good for like a ray tracing or something, maybe. Something where you shoot stuff out from the camera. Anyways, let's add these together. Right click, create node, add. Hide the preview. And then we're going to drag the output from multiply and the output from position into here. So it's basically, it's creating that offset for the water, and then we're just going to add that to the position of the vectors. So, okay, so that's why we use the normal vector above. The normal vector is just the up direction. In this case, since we have a flat plane, so what it's doing is it's taking that noise and it's saying, okay, we want it to go up and down. That's what multiplying is doing, putting those together, and then we will add that offset to the water. So now the noise is going to make it go up and down to the position. And then after we add them together, that is, I think, it. So if you want to just drag that into the vertex position, yeah, you can see the preview in the bottom left is going a bit nuts. It kind of looks like somebody having a panic attack in one of those TV shows. So it's doing what we want it to do, but it's doing it a little bit too fast. I think, I can't remember if I need to change the speed of time or the scale. I think it's both. But I don't remember what I set them to. So let's change the time speed first. So we're going to actually come back and edit this a little bit. And I did this on purpose so you can learn. Go ahead and click on this link between time and tiling and offset, and then just hit the delete key on your keyboard. I think you can also like right click it and hit delete or something. So we're just going to remove that because we're going to insert something in here. So if you want to, you can drag time a little bit to the left. And we're going to insert a multiply node into here. Same as before. Basically, we're just going to take the time and multiply it by a really small number so that it's not as fast. Because the preview right now, it's like really jittery, and that's because it's just moving way too fast. So we're going to slow it down. So underneath time, I'm going to right-click, create node, and make one, or actually, yeah, let's make a variable. So shaders also allow for you to send values to them from your C# code, which is really nice. Say that you have some value you want to use, maybe an object of the, or like a position for the light. You want to know where the light is. Well, the shader doesn't know that by default, but what you can do is you can create a constant value that will, or not constant, but a value that you can use, that you can pass from the CPU into the GPU and then use that in the shader. So in this case, let's just hit this plus over on the left side where you kind of see this area, and then hit float. So we just want a singular number, and I want to name this speed. Then if you click on it, you can see on the right side on the graph inspector, it kind of has some different stuff about it. I'm just going to change the default to 0.01, I think. Do 0.01. And that'll just slow it down a bunch. That might be too slow, but we can change it again. Normally, you would set this from the outside, but we can also set a default value, which is nice. So if you don't set it from C#, which we're not doing, you can just have it default to something. So if we want to actually use this variable, you can just select it from the left side and just drag it into the area with all the nodes. And it'll create a node for it. You can see how it says speed. And then the type, which is a float. And then we're going to basically multiply the time and the speed together. So pretty straightforward. Drag those both into the multiply. And then take that output and put it back into the offset, which is where we had it before. And now you can see the preview is not freaking out, which is nice.
Okay, speed it up a bit.
Yeah, if you want to speed it up a bit, just to make sure it's working right, it'll be more obvious when we actually apply it to an object. And then one more thing too. Let's actually check it in the scene. So after you've done all that, hit save asset in the top left, and then navigate back to the scene view. See if we can actually see it in action here. So it's the same situation as the cube that we did earlier when we applied it. You want to click on the water plane. And then on the right side, make sure you can see the material slot. And then down below again, we'll have this water material. We can drag it into there. And yeah, so you can see it kind of jittering around. And the reason for that is because even though, like the way that shaders work is it's constantly going even in the editor. And the reason why it's kind of jittery or like it skips around is because Unity doesn't constantly update the scene view, and that's just to save on like electricity and processing power. If you want to actually see it moving in real time, you have to play the game or just like constantly move your mouse to update the window, which is kind of annoying. So I'm just going to hit play. It'll be a lot easier. So yeah, it's a bit of finagling, but that's for you to mess around with if you want to. This is just basically how to make a vertex shader. Pretty simple one. You can also do other things. Unity has like a bunch of cool like examples. So, yay, we did a vertex shader. You can go ahead and close these windows if you want. I'm just going to right-click on it and close tab. We don't need them. Okay. And then let's right-click and create a new shader in our shaders folder. Right-click, create shader graph, URP. Honestly, we could do unlit for this one, I think, because that would make it the cartoon shader actually look a little nicer. So let's do unlit and call it like toon shader. So basically, the difference between lit and unlit is that one has light and shadows and the other one doesn't. So. And as you can see, there's a lot less options in Fragment, and that is because we have full control over what color the pixel is. There's no, Unity's not doing anything on the outside. It's not doing the lighting. So we don't have to mess with any of that stuff. Again, I'm going to make this bigger. That's easier to see. Okay, so this one, we're going to actually use the previews. So in this one, we actually want to use a variable that we will be changing. So one of my scripts does change the thing, and it's exactly what I talked about earlier. We have a light source, and we want to be able to know where it's at in the scene. So let's, on the left side, before we create any nodes, let's create the variable, hit the plus, and then we are making a vector 3. Yep, vector 3. Call it like light pause or something. Whatever you want to call it. Actually, yeah, whatever you want to call it. And then we'll drag that into here. Far out on the left side, just so we have lots of space. Actually, I'm going to go even further. Very far out. Yeah, far out, man. So yeah, we're going to take this light position, and then we are going to normalize it. So create node, normalize. If you don't know what normalizing does, I'm going to minimize that. Normalizing basically takes a value and then makes it so all of them, when combined together, are equal to 1. Or when they all added together, it's equal to 1. So in this case, essentially what it's doing is it's taking that light position, say it's at like 332 or something, it's up in the sky, and then we're taking the direction towards it. So it's creating a smaller version of that direction pointing to it. Because essentially the position is just like an array being pointed out to that specific spot. So if you normalize it, then now instead of getting the raw position value, now we have a smaller vector that's just pointing to it, which we will be using on our object. Essentially what we're going to do here is we're going to create our own custom shadow on the object, but have it look a little less smooth, and we're going to have like some different layers to it to make it look like it was in a cartoon or something, make it look fancy. So in addition to the that we just did, we also need our normal vector again. Seems to be a common theme here. So create node, normal vector. Minimize that. However, this time we will not be changing it to object space. We are keeping it in world space. And this is because, like I said earlier, we have the light source, we have our normal vector, like we want to make sure they're all in the same space. Since we're not dealing with just the object, we actually care about other things other than the object, we'll keep it in world space. Okay, and then now we're going to do some math. Basically, we're going to do a dot product, we're going to multiply it, and then we're going to add it. The dot product, I'm trying to make sure I get this right. Basically, the dot product takes the angle of the light towards the surface, and it will give us a value between 1 and -1. And so we can use that value to then determine how much light it's getting, in which case we can also determine how much shadow it's getting. So let's go to create node and then dot product. And this time I will leave the preview on, and you'll see why. We're going to drag in the normal vector and the light position normalized. Let's set this to just an arbitrary value for the time being, like 333 or something. Yeah. Go ahead and click on light position or whatever you named it, and change the default to 333 or like some value like that. And this is just so we can see a preview. If it's 0, then it's going to be pink because it doesn't have anything. And then we're basically going to take this dot product and we're going to get it so it is scaled between 0 and 1. Right now it is between -1 and 1, or the possible like domain range of the dot product. And we want to get that so it's only 0 to 1. So we'll go to create node and then multiply, followed by a create node add. And then we will drag the out into the top one. We want to multiply it by 0.5, so we're going to change this bottom value. And then we'll do the same thing here. We want to add 0.5. So basically it's taking that range of -1 to 1. So it's taking that value, taking it from -1 to 1 into -0.5 to 0.5. And then we're adding 0.5 so it gets between 0 and 1. Now you kind of see this pattern on here, which is a good sign. And then we're going to plug that into a vector 2 so that we can reference it to a texture. So you don't have to follow along here, but in the textures that I gave you, one of them is called Tune, this one here. And basically, it doesn't need to be this thick, but basically what we're doing here is we're going to take that 0 to 1 value, and that's going to be used as a coordinate on the texture to determine what color we're going to create for the shadow. So white would be somewhere that is completely in light. You have gray, like the lighter gray, which is like kind of shadow, and then you have the dark gray, which is the complete opposite side from the light source, so the darkest part. And you could make this whatever you want. You could. The reason why this is kind of cool is because if you want a tune shader, you can modify it pretty easily by just changing this texture to, if you want it more dark or something. So yeah, let's create a node vector 2. And then we're just going to plug the result from add into the top value. Yep. And then just leave the bottom one as 0. It doesn't matter. And then we have 2 more nodes to add. First, we need to get the actual texture we want to render. So up above, I'll do create node, sample texture, like we have done every other time. Oh, sample texture 2D specifically. Okay. And then I'm going to select the GDC logo. And lastly, to combine these values together, we're going to multiply. So take the wait, did I miss something? Oh, I did. Whoops, my bad. Cringe, I can't believe it.
Yeah, I'm actually disappointed.
I need to move these over a tiny bit. So if you want to move everything at once, if you zoom out with your mouse wheel, you can like a Windows desktop, you can just kind of click and drag and then click on one of them and drag everything. Okay, so after that vector 2, we actually put that into another sample texture. Sample texture 2D. And that's what I was talking about before with that toon shader texture. So again, we will select the toon texture. It'll look like this. So we take the output from that vector 2, plug that into the UV. Now it'll look like this, which looks a lot more like a toon shader texture on a sphere. So you kind of get what I'm going for here. And then we will multiply the texture that we want. So we'll take the color of the toon shader, and we will multiply that by the texture, basically applying that shadow. So if it's white, it doesn't actually like do anything. It's just whatever color the texture is, and then the grays will make it darker. So we'll drag the two color values, the RGBA. Sorry, it's really tiny. Let me make it bigger. Take those RGBAs into the multiply, and then that multiply is our final result, which actually if I leave it like here, then you can see it. So put this into fragment base color. Yeah, so yeah, if you wanted like more layers to it, you could add more colors. You could even make the texture bigger. Since it's always 0 to 1, you don't have to rechange the texture or the shader if you change the texture, which is nice. So after that, go ahead and hit Save Asset. And we'll go back to the scene and we will apply it to the sphere that is still pink. So cartoon sphere, same dealio. We will take the toon shader material and we will apply it. However, oh, it still makes a shadow. That's okay. If you are a keen observer, you will notice that the shadow is not facing the light source. Yes. So that's what I was talking about earlier with the scripts. Luckily for us, if we go to the directional light, so it's in the, it might be hidden, but under the drop down for light center in the hierarchy, there's also directional light. One of the scripts I made will take the material, so it'll take the data for the shader that we're passing in, which is basically what a material is. It'll take a reference to that material and then the name of the light value, and it will basically automatically update it, update the position of the light in the scene. So when you run it, it'll actually work. So we'll change the material reference to the material toon shader. You should just be able to find it in the quick list. If not, you can also just drag it into here like you did with the other thing. And then one tricky thing. So it says light variable name. There is a difference between what you name it and what Unity names it. Because they have like a naming convention, so they force it to follow that naming convention for some reason. So if you want to find out what the name is, usually it just adds an underscore to the beginning of it, but sometimes it's different. So just to double check, if we go to our toon shader again and click on our variable, on the right side you can see name and reference. You can actually change the reference, so if you want them to be the same, the name and the reference, you could probably just do that. But I'm just going to use the default one. I'm going to copy it. So the reference is what the C# code needs to actually use to set the value. And then the name is basically just a name in the shader graph. It's nothing else. So I will go back to this object in the scene, the hierarchy. The light variable name, we will paste in the reference name. And then I will hit Control S, save the scene.
Wow.
And it should update when we run the game. So yeah, now you can see the tune shader is getting those white values, the gray values, and the dark gray. If we did black, this would be completely black. You usually don't want complete blackness unless like that's what you're going for. But in normal situations, that shadow isn't completely black. So, and then yeah, right now, all the scene is doing is the light is rotating. It's taking that light position, sending it to the tune shader, so the tune shader knows where the light is. So it kind of matches up with the shadow. And if we want to actually open the script and see what it does, I can kind of explain that too. Look at this really long script. So, yeah, all this is doing is it takes that material and takes the light name, and then it will set a vector in the material, whatever name we give in the editor, and then it'll set it to the position of the light. Since this script is on the light itself, it just uses its own position. And then I forgot the debug statement that's just in there. So. Then the other script I have, I think it literally just takes whatever object it is and just spins it, so pretty simple. With the tune shader, when we created it, we told it to make it unlit. So that one, right now, this is completely ignoring the light source. If I were to just disable the directional light, you can see how this one is still kind of lit up. And that's because it's not taking in light, it's not putting out light, it's just using whatever colors we told it to. Whereas like the box and the water, if we made the tune shader with them and we wanted reflections, like we could also somehow do that. It's a little more complicated, but you could. Well, I'll go through a couple more announcements and then we will be done. So again, please go vote for the t-shirts, especially if you paid for one this semester or last semester, because we will be ordering them soon, probably next week sometime. So try to vote by next meeting. That'll be the deadline, I'd say. And then we'll order them after that. If you haven't ordered a t-shirt this academic year and you would like to get a t-shirt, please come talk to me after the meeting since Jimmy's not here. We'll work it out. Yeah, so next week we will be doing world building as a meeting. We are going to have a fun activity with props. So, yeah, if you want a fun meeting, you should come next week. It's not inspired by the person that we had come and talk, ironically enough. That was just coincidence. But we'll talk about some world building ideas, how to generate ideas for a world and a story that incorporates everything in. So